Next topic we'll study about the power measurement by 2 watt meter method. As its name suggests, 2 watt meter means we 2 watt meter, right? So what is watt meter? Watt meter is a device which is used to measure power. Like you have studied na voltmeter, it is used to measure voltage. Ammeter is used to measure current. Similarly, we are having watt meter, and watt meter is used to measure power. So we are having symbol of wattmeter. We are having two coils. One is the like inductive coil, another one is the resistive coil. The first one coil called as technically as CC. CC means the current coil. Okay, and this one resistance will call it as PC. PC means the potential coil. So this is the symbol of the wattmeter which you need to remember. Current coil is mainly directly connected with the line. Potential coil is connected with the another line. As I draw the diagram for the star connection, like suppose we are having a star connection like this. Okay, so it would be R here, Y here, B here. Suppose how much current is flowing in this, that would be IR. Here it would be IY. Here it would be IB. Okay, so we have to use 2 watt meter. We can use any 2 watt meter R in R, Y or B. That depends on you. I am using the watt meter in R and Y. Okay. You can use the watt meter in Y and B. You can use the watt meter in R and B. So one of the watt meter I connected with the R line. As I told you, current coil is connected directly to the main line and resistance coil is directly connected with the another coil. Another coil means another wire, that is B. So this is wattmeter 1, that is represented by W. Next is the wattmeter 2, again the current coil and the potential coil, like this. This is a wattmeter 2. Okay. So in this case, how much is the voltage? As it's a star connection, so we'll have neutral point also. The voltage between R and N is VRN. The voltage between B and N, that would be VBN. The voltage between Y and N, that would be VYN. Right? So as you know, the power formula is how much? Power is how much? VI cos phi. If I'll see according to W1, W1 is connected with which line voltage? W1 is connected with R and B, right? So that would be VRB. So as you know, the formula for the power is how much? VI cos phi, correct? So voltage is how much in this with the wattmeter 1? Wattmeter 1, the voltage is this voltmeter is connected between R and B, so we can consider the voltage as VRB, right? Now the we'll see the current. Now see according to the current is how much flowing? Tell me, current is how much? Current is IR. Current is IR and cos of 30 minus phi. I'll tell you through the phasor diagram that how this 30 minus phi came. Okay. Now similarly we have to tell the value for the W2. W2 is voltage is how much? Voltage is how much? VYB, right? Because it is connected with the wattmeter Y and B, VYB, and the current is how much? This wattmeter is connected with Y, so that would be IY cos of how much? 30 plus 5, right? Okay. So we got the value for W1 and we got the value for W2. So we'll do one thing. Once we'll add W1 plus W2, then we'll subtract W1 minus W2, and then we'll divide with each other. Okay. Now see in this case, as you know that W1 is how much? VRB is the line voltage or the phase voltage? VRB is the line voltage or the phase voltage? Tell me. It is moving across the line, this R and Y. So it would be the line voltage. Okay, VL. IR is the line current or phase current? IR is the line current. So that would be cos of 30 minus 5. Similarly, we are having W2 also. VYB is the line voltage, so we'll mark VL. IY is the line current, so we'll mark IL cos of 30 plus 5. Okay, got it? So now if I'll add the W1 plus W2, then it will become VL IL cos of 30 plus minus 5, then VL IL cos of 30 plus 5, right? So can we take VL and IL common? If I'll take VL IL common, then that would be cos of A minus B and that would be cos of A plus B. So if you remember from the school level, the formula for the cos of A minus B is how much? Cos A, right? Cos B plus sine A and the sine B, right? Similarly, if I'll do it for the cos of A plus B, that would be cos A cos B minus sine A and sine B, right? If there is a positive, then we'll mark negative. There is a negative, then we'll mark positive. Correct? So if we'll further solve it, that it would be VL IL cos 30, you know, all the things, and some of the things would be cancelled out. After solving it, we'll get how much? That is root 3 cos 5. So the final answer we got it for W1 plus W2 is root 3 VL IL cos 5. Got it? This is for the W1 plus W2. Now similarly, we'll do it for the W1 minus W2. Now I am not solving, but I am telling you the direct value. For W1 minus W2, we'll get it as VL IL sine phi. Okay. So now we'll divide the thing W1 minus W2 divided by W1 plus W2. W1 minus W2 will get it as VL IL sine phi divided by that would be root 3 VL IL cos phi. So VL IL that would be cancelled out, right? Root 3 can be shifted over here. So that would be root 3 W1 minus W2 divided by W1 plus W2. Sin phi by cos phi is how much? Tan phi, right? So can we get the phi value from here? That this tan will be shifted over here, then it would become tan inverse root 3 W1 minus W2 divided by W1 plus W2. Correct? Sometimes they'll ask you the power factor from the 2 wattmeter method. So the power factor is how much? Cos phi. If I'll multiply cos with the right hand side, then we need to multiply cos with the left hand side also. So that will become your final formula which you need to remember for the numerical purpose. And in Manipal, there is a chances like Manipal University, one question they'll give from the power that this based on this formula, and one question they'll give either from the star, either from the delta. So there are only three topics. This is very scoring three phase. There are only three topics. What are the three topics? One is the star, another is the delta, and another one is the power measurement. And from these three topics, two topics will definitely come. Okay, so that's why it is very scoring. Now the question is that I told you that I'll tell you later on how this angle come 30 minus 5 and 30 plus 5. That will come through the phasor diagram. Okay, let's draw the phasor diagram. We are having three line current, correct? One of the line current is IB, another of the line current is IR, another line current is IY, correct? Now as you know, it is the case of inductor. So in case of inductor, voltage always lags current, right? Voltage lags current, so voltage will be make behind like this. If it's IB, then we'll mark it as VBN. If it's IR, then we'll mark it as VRN. And if it's IY, then we'll mark it as VYN. Okay, and the angle between voltage and current is how much? Phi. Angle between voltage and current is how much? Phi. Got it? So angle between the three line current would be 120 degree, like IB, IR, IY is 120 degree. So you can write down angle between IB, IR and IY is how much? 120 degree. And the angle between VBN and IB is how much? Phi. Got it? Now, as we already draw the component VRN and V, can we extend VBN like this? It would be a straight line. Okay, if here it is positive VBN, then we'll mark it as here minus VBN. Got it? So as you know, we are having two component. One of the component is VBN and another of the component is VRN. Can we draw a single voltage? Like remember in the phasor diagram of star connection, we draw the single voltage, then we'll draw the two component. But in this, we draw the two component, then we'll draw a single voltage, right? So that would be how much? Remove N and N, that would be VRB, correct? Like it would be like this. Similarly, VYN and VBN, these are the two components, right? We'll mark a single voltage, that would be how much? Remove N again, that would be VYB, correct? Okay, it looks like complicated, but if you revise it by your own, then you can do it. Okay. Now see the angle between voltage, phase voltage and the line voltage is always 30 degree, as you know. Angle between line voltage and phase voltage is how much? 30 degree. So can we say that VRN is the phase voltage? Wherever N is come, that would be the phase voltage. And VRB is the line voltage, right? So the angle between the phase voltage and the line voltage is how much? 30 degree, right? Angle between the line voltage and phase voltage is 30 degree. Again now this VYN is the phase voltage, VYB is the line voltage. So angle between line voltage and phase voltage is equal to 30 degree, correct? Now see, we have to see which angle, as I told you through the diagram, that we need the current angle between VRB and IR, right? We need the angle between VRB and IR. Let's see what would be the angle between VRB and IR. Now you tell me. They are demanding for this angle. If the total angle is 30 degree and this angle is 5 degree, then angle between VRB and IR is how much? 30 minus 5? Yes or no? Okay. So now see the next angle which we want. We want the angle between VYB and IY, right? We want the angle between VYB and IY. So now see the VYB is this one and IY is this one. So they want angle between these two. So this one is 30 degree and this one is 5. So that would be 30 plus 5, right? So this is the final phasor diagram. Got it?